Chemtech Laboratory Tutorial. Today we'll be looking at the second episode of gas law, and that is Graham's law of effusion. Graham's law of effusion simply explains how gases escape through a tiny small hole, and these gases escape based on their molecular weight. The gas that has a lower molecular weight escape faster than the gas that is heavier in their molecular weight. So what does this law explain? It states that the rate of effusion is inversely proportional to the square root of their molar masses, and that is given as R equals to 1 all over square root of what? Molecular mass, and this we have it to be this. And therefore, when the gases are 2, it becomes R1 all over R2 equals to molecular weight of 1 all over molecular weight of 2. And how is that done? By the relationship, we have 1 square root of m. If it's 1, that means the ratio becomes R1 all over R2 equals to 1 all over square root of n1 all over 1 all over square root of n2. And we know that R1 all over R2 will be square root of n1 times square root of n2 all over 1. So we simply simplify it to be R1 equals to R2 square root of n2 all over square root of n1. So this is the general formula for Graham's law of effusion. So taking the question now, we will now take an example. We say if it takes 1.25 minutes for 0.1 moles of helium to effuse, how long will it take for the same amount of ethane to effuse? And remember that the time taking also matters. So if we are introducing time taking, it becomes T1 all over T2 equals to what? N2 all over what? N1. Because rate talks about the speed at a particular time where the gases will escape through a tiny hole. So in relating that, it becomes the time is measured in seconds, but the time given to us is in minutes. So it means that it's either you convert to seconds or you work with minutes and thereafter you convert it to what? Seconds. So in converting minutes to seconds, we say 1 minute is equals to 60 seconds. Therefore, 1.25 minutes is equals to 60 times 1.25 to give us in seconds. So when we multiply that, we will have 75 seconds. So it will be 75 seconds that it will take for helium to travel through the same with 0.1 mole. So that of ethane, we have to calculate the time for ethane to travel. So, and in calculating the time, we assume that the molecular mass for helium is equals to 4 grams per mole, and that of ethane becomes 12 times 2 plus 6 times 1, which is equals to 30 grams per mole. And therefore, putting it into the formula as T1 all over T2 is equals to square root of n2 all over n1. So it means our T1, putting the value into the formula, we have T1 equals to 75 seconds, which is 75 all over T2 A6 equals to the molar mass of 30 all over square root of what? 4. When you cross multiply, you have T2 A6 is equals to 75 times square root of 4 all over square root of 30. And that will give us C2. The time taken from ethane to travel becomes 27.27 seconds. Thank you. and keep on watching Chemtech Laboratory tutorial. Like, share, comment and subscribe.